Systems of inequalities can also be used to help us in solving word problems. Let's take a look at an example here. A person plans to invest up to $2,000 in two different interest bearing accounts. Each account is to contain at least $500. Moreover, the amount in the second account should be at least twice the amount in the first account. Find and graph a system of inequalities to describe the various amounts that can be deposited in each account. So, as with any word problem, it's always a good idea to think about labeling variables. What are we trying to find? We are trying to find and graph the system that describes the amounts that can be deposited in each account. So, we have two accounts. That means we need to find the amount in account 1, and we need to find the amount in account number 2. And because we have two variables, let's call them x and y respectively. X is the amount in count 1, y is the amount in account 2. Now let's see if we can't come up with some inequalities based on the information that we have. A person plans to invest up to $2,000 in two different interest bearing accounts. So $2,000 would be the maximum amount that they can invest. That's the maximum amount of money they have to invest. That means the sum of x plus y, the amount in each account, must be less than or equal to 2,000. X plus y is less than or equal to 2,000. Also, each account is to contain at least $500. That means the amount in each account must be greater than or equal to 500. In other words, x is greater than or equal to 500, and y must also be greater than or equal to 500. Look for keywords like up to or at least. Again, greater than or equal to $500. That would be 500 would be the minimum. Moreover, the amount in the second account should be at least twice the amount in the first account. The amount in the second account, what did we label as the amount in the second account? That was y should be at least, that means y must be greater than or equal to twice the amount in the first account. Well, the amount in the first account was x. That means y must be greater than or equal to 2x. And there we have developed our system of inequalities. We have four inequalities in this system. Now, just like with all our other inequalities, we want to begin by graphing each of the equations. So we start off by graphing x plus y is equal to 2,000. Well, this is going to be a line, and it's written in standard form, ax plus by equals c. And whenever we have a line written in standard form, it's easiest to plot that line by graphing or plotting the intercepts. Notice if I plug in 0 for x, I get y is equal to 2,000. There's my y-intercept. And if I plug in 0 for y, I get x is equal to 2,000. My x and y intercepts are both 2,000. We connect the dots there, and we end up with our first curve. Notice that we used a solid line because of this equal to component. And actually, all of these lines are going to have solid lines. Next, we have x is greater than or equal to 500. Well, we graph the line x equals 500. That is a vertical line right here where all the x values are 500. Next, we graph the line y equals 500. That's a horizontal line where all the y values are 500. And finally, we need to graph the line y equals 2x. This is a line that passes through the origin and has a slope of 2. That means we go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. There we go, up 2 over 1. Up 2 over 1. All right, and so we connect the dots there, and we have our last line. All right, to solve the system, now we have to determine the region that we want to shade. Let's start off with our first inequality here and choose a test point. Now, for our first inequality, the easiest test point is going to be the origin. Let's test 0, 0. If we plug in 0, 0, we get 0 plus 0, which is 0, is less than or equal to 2,000. That is a true statement. So we want to shade to the side of the blue line that includes the origin. That would be down and to the left. Next, x is greater than or equal to 500. Well, if we want x values greater than or equal to 500, that means we want to shade to the right of our red line. And if we want y values that are greater than or equal to 500, we need to shade above our green line, y equals 500. And finally, y is greater than or equal to 2x. Now, we cannot choose the origin here because this line actually goes through the origin, but we could pick any other point that is not on this line. An easy one would be 200, comma, 0. If I choose 200, comma, 0 as a test point, plugging in 200 for x, that gives me 0 is greater than or equal to 2 times 200. 0 is greater than or equal to 400. Well, that is absolutely not a true statement, which means we want to shade the region that does not include this test point, meaning for our purple line here, we want to shade up and to the left. So where do all of these shadings intersect? Well, we got to go down from the blue, above the green, left from the purple, right from the red. That gives us this little triangle in here for our solution set. Okay, that shaded region gives us the various amounts that can be deposited in each account.